This is our video presentation for our group assignment, application of differentiation. Our group name that we choose is INA.
Acknowledgement. I wish to express my sincere gratitude to Sir Shafiq bin Abdul Rahman who gave us the golden opportunity to do this wonderful project of calculus. We are really grateful because we managed to complete this video presentation with the time given by our lecturer. This assignment is impossible to be done without amazing cooperation and effort of our group member. We also sincerely thank our lecturer Sir Shafiq for the guidance and willingness to help us in what we are lacking when completing this assignment and surely for teaching us this course. Last but not least, we would like to thank to our family members who keep on encouraging us all this time.
Our group member consists of 3 members, which is me, Azra Izzah binti Abdul Rashid, and then NORALYAA MAISARAH binti ZAINAL ABIDIN, and IZMEEN NADIRA binti ROZALI. The topic that we choose for our group assignment is related rates. What is related rates? In problem involving related rates, there are at least 2 variables that we change at the same time. Though they might do so at varying rates, the idea is to determine how quickly one thing is changing based on how quickly something else is changing, which may be more easily measured. Once a relationship between the 2 quantities has been established, we can use the chain rule or implicit differentiation to determine how each variable changes over time.
Why do we use related rate? Using the rate of change of another quantity, we can determine how quickly or slowly a particular quantity is changing by comparing it to the rate of change of the second quantity. What is differentiation? Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables.
When do we apply differentiation? One of the applications involving geometry and function. This is the main and most important way that derivative is used. For example, we can use the derivative from dy dx to find out how fast the volume of a cube changes at its side gets smaller, where dy is the rate of change of the cube's volume and dx is the rate of change of the cube size.
What are other applications of differentiation? In real life, we can calculate the profit and loss in business using graph. Next is we can check the temperature of variation. Lastly, we can determine the speed of distance covered such as miles per hour, kilometer per hour. Problem statement. A spherical balloon is deflated at a rate of 12 cm3 per second. Find the rate of change of the surface area when the volume is 36 pi cm3.
Objective. First, to understand related rate or rate of change problem involving geometry formula and function. Next, to solve the related rate using chain rule method and implicit method.
This is our diagram of our problem statement.
Problem solution. We need to choose one method to solve this problem. To solve this problem, we will use the implicit differential method.
Step 1. We need to draw an appropriate figure and label quantities given related to the problem for better understanding. Step 2. We need to identify the problem that we need to solve. And then we need to find the related formula from the question, such as area and volume. The area and volume, we need to write the equation that relates the quantity of the interest.
Step 3. We need to find the radius from the formula given over the volume from the equation. Step 4. By the formula of spherical area, we need to differentiate the equation.
Step 5. Using the implicit method. The differential result need to multiply with the rate of change of the volume. Step 6. Substitute the radius that we find in the equation. By that, we can get the final answer. Conclusion. In terms of a conclusion, one thing that we can take away from this discussion is an appreciation for how to solve problems involving geometric formulas and functions that involve related rates or rate of change. In addition, we are able to find a solution to the problem of related rate by employing the chain rule method and the implicit method.
Problem resolved!
That's all from us. Thank you.